Hello everyone, this one is a calculator Olivetti model 245 from 1971. It has some particularities. The main one, I think, is a memory that is made by a single thin nickel wire with a signal running on it similar to an echo. I will show later. The calculator can be easily opened. It's divided in blocks, so maintenance is very simple. Do you see? Printer, power supply, main motor, keyboard and electronic board under here. There is a fan for the cooling of the electronic parts. It uses an interesting impact printer with 28 columns. It works at about 30 characters per second. The ribbon is here, and it goes all the way around the printer. The impression is made by this hammer in the front, hitting the roller with all the digits. There isn't the display, so the result was printed only on the paper. It was considered more professional, because the numbers on display disappear, but the paper remains. The memory is a very particular acoustic delay line memory. It's here on the main board. It's made of this nickel wire 2.5 meter long, 8 feet, that wraps around this electronic board. It's based on a characteristic of the nickel wire. When stimulated by a short electrical signal, it generates a small mechanical torsion that travels from one end of the wire to the other, like a wave. It starts from here, where this transmitter sends, at very short and regular intervals, electrical pulses that generate a twist in the wire, which is interpreted in binary code as 1, and the absence of twist, which is 0. Then this other sensor receives the signals. The electronic board here sorts the signals, add other data arrived or delete used data, and retransmits the signals that still need to be kept in memory to the transmitter. The data continues to flow along the wire many times a second without ever stopping. In this channel there is already a detailed video about it. I leave the link in the comments. This is the keyboard. It's without subkeys, as you can see. Here's how it works. Under this electronic board on the side of the keyboard, there are some magnets, this one. Corresponding to the magnets are switches that change state depending on whether they are in contact with the magnet or not. When you press a key, these metal bars move and cover or uncover these small magnets. So it's the movements of these bars with the magnets inside the keyboard that change the state of the electronic switches on the sides, thus generating a specific code for every key pressed. Don't you think this is the coolest keyboard you have ever seen in the last week? It's a calculator from 1971. Olivetti was going to embrace electronics. They had already produced a mainframe digital computer, the ELIA 9003, in 1959, and a programmable calculator with transistors, the Programma 101, in 1964. In the late 1960s, they produced the Logos 328, their first electronic desktop calculator, and in the 1970s there is the 200 series with this Logos 245. At the bottom of the flyer there's a note: no room conditioning required. This is because the line delay magnetostrictive memory used on this calculator could be affected by outside temperatures, which could change the transmission speed along the nickel wire, corrupting the data. So they specified in red that it could be used at room temperature. Let's see the electronic board. There are 159 electronic components with 14 pins on this big electronic board. It was very advanced for that period. Now all this would be concentrated on a single chip with also many additional functions and much faster. The keyboard performs the 4 basic arithmetic functions, with also the functions of constant numbers and accumulation of numbers in memory. That's all for this calculator. I think it has very interesting and unique solutions, and it clearly shows how at the time we were moving from mechanics to electronics, and we were still in a mixed situation. Here there is the video to a similar calculator of that period, the Olivetti Logos 58. Have a nice day.